Today we're going to continue on graphing quadratic equations as a method of solving, but we're also going to look at the different parts as we solve those. You'll need a graphing calculator for this, of course, and we will take a look at a few things. The first thing we need to take care of is to make sure that the equation is in a form that we can graph with our calculator. Very simply put, get y by itself. It's nice to have it in slope-intercept form, but it doesn't have to be in the correct order or anything of that nature at all. We just need to make sure that everything is set equal to y, and then when we graph, we'll be able to take a look. And when we do this, what we're doing is find where y is equal to 0. So we can see that the y is on the left side. Doesn't matter which side, as long as we get it by itself. So I'm going to move the 9x over by adding 9x. And at the same time, I'm going to move the x squared over by adding x squared. Now, when we do this, what we'll end up with is the equation y equals positive x squared plus 9x plus 18. Now, we're going to talk about several parts. Like I said, we're going to talk about the solutions, which is where it crosses the x-axis. That is the most important part. When it crosses the x-axis, that's our solution. We're also going to talk about where it crosses the y-axis. That's where the x value is equal to 0. We're also going to talk about the vertex and axis of symmetry. We'll move into those later, but while we have these graphs, I'd like to just go ahead and introduce these things. All right, now, as I said, we've got our graph, and I've graphed these earlier on. So we will take a look at what we have here. Hopefully. So as you can see, I have my graph here. My y equals x squared plus 9x plus 18. And I want to highlight these key parts. The main ones I want to make sure that we always understand is our solutions, the x-intercepts. This is where the y value is equal to 0. So we have a solution at -6. We'll go ahead and graph this as well. We have the point -6. And if you look a little further down, we also have the point -3. So those are our solutions. So if they're solutions, they're also crossings at the x-axis. We can plot all these other points as well. What I want you to notice as well is my y-intercept. We have a little bit of a problem because our y-intercept is off the screen. But our y-intercept happens when x is equal to 0. So what we're going to do is go through and just plot all these other points that we have. We have a point at -7, 4. We have a point at -5, -2. We have a point at -4, -2. And then what I want you to notice as well is the symmetry that we have going on here. And we have a point at -110, which is off the screen. Notice the symmetry that we have on this thing. We have a 4 matching. We have the 0s matching. We have the -2s matching. All parabolas have this symmetry. So what we have here is when we graph this thing, parabola that's going to curve like this, and then eventually it's going to cross at 0, 18. So let's identify the different parts that we have. We have x-intercepts, multiple ones, at x equal to -6 and x equal to -3. We have a y-intercept. Now the y-intercept is always going to be the constant value. The constant value, of course, is the value that does not have a variable. So our y-intercept is going to be at y equal to 18. If you want to write these as ordered pairs, that would be a good move as well. Now the next terms that you're not familiar with is the axis of symmetry and we will get into these a little deeper. There's a formula for this, but we will just talk about this on the graph for now. And then the other part that we need to know is the vertex. Now, in knowing the axis of symmetry, we already know half of the vertex. The axis of symmetry, first of all, is an x equals value. Well, the axis of symmetry is, like we talked about, the symmetry. Well, we have a symmetry surrounded around the point directly between -5 and -4. Because from there on comes our symmetry, -2, -2, 0, 0, 4, 4. And if we looked even further, we would see more and more symmetry. So our axis of symmetry would be the x value, -4.5. Would be the x value, -4.5. So what the axis of symmetry is a vertical line that goes through the vertex of our parabola. Now, once we have our x value, we do have an equation here as well. So what we could do is we could plug in our value into our equation, or since we have a graph already established here, we could look up the value -4.5. And when we have that, we will have our vertex. I'm going to go to my calculator and see what this value is. So what my calculator tells me is that when -4.5 goes in, -2.25 comes out. Now, what I did was I just went to my calculator and I hit second and then the calculate button. And then you can put in, the first option actually is value. And then you just type in the value that you're interested in. I typed in the value -4.5 and it told me -2.25. So this is our axis of symmetry. This is our vertex. You will always have the axis of symmetry as the x value of the vertex because that is the absolute highest and lowest point, or lowest point, correction. And that brings us to our last little bit, which in this case is, since it is opening upward, if it's opening upward, we have a minimum value at y equal to -2.25. So those are all the points that you'll notice that sheet is asking you for. They're all very much related. The minimum is the y value of the vertex, the axis of symmetry is the x value, and the opening we can visually see what this is doing. What changes the opening is the value in front of the x squared or attached to it being negative. And we will see a couple of those. So what you should notice on this one immediately is this is a completely different form. We have y by itself, so we're set. The calculator can completely understand this, but we will also learn later that this is known as the vertex form. The reason why it's called vertex form, you'll learn, we'll hold off on that. Actually, don't want to spoil this one for you, but this is known as vertex form. We'll explain why that is in just a moment. But what I want to look at first off is what happens when I put it in my calculator. So now you can see this is in my calculator. I typed it in just like it was. And this is the table it gave me. It says -12, or -212, excuse me, which is off my graph. So I'm going to start with -1.7, which is on my graph. There's a point at 0.4. That is the y-intercept. There's a point at 1.3. 2.4. Now there's our symmetry again. You can see that it's reflecting across that different spot. A little too low, should be 7. And then the other one's off the screen as well. So what we end up with is a parabola that looks a little something like this. Let's notice a few things. First of all, this is opening upward. If you think of a cup, this is an upward opening cup, smiley face, whatever you want to call it, that's what we have. Want us to notice as well, we have a y-intercept And notice this one is not at that constant value because we don't have this in standard form. So since we do not have this in y-intercept or standard, excuse me, I said standard, y-intercept form, the constant value will not necessarily be that. So our y value, where it's equal to x, is where this is our y-intercept. Where x is equal to 0, excuse me, is our y-intercept. Let's talk about what else we have here. Let's do the axis of symmetry. We can visually see this on our graph, but I want you to notice this on the graph as well. The axis of symmetry is always going to be the part that does not have a matching pair. Here's what I mean by that. We can see that the 12 is pairing out here and here. The 7 is pairing out here and here. The 4 is pairing out. And the 3 is not. Anytime you have a value that is not pairing out, that is your vertex. And if we know the vertex, we also know the axis of symmetry. Remember, the axis of symmetry is the x value at the vertex. So our axis of symmetry would be 1. Our vertex will be, it's a location, it's located at 1, 3. Since this graph has a valley here, we don't have a maximum because that's what those arrows mean. They continue on forever. So we have a minimum value in this case, and our minimum value is at y equals 3 because we will not go lower than that. And then the next part, the most important part when we're solving, is the x-intercepts. But we can see the shape of this thing and where it's located. It does not, nor will never, cross the x-axis. So what that means is there are no x-intercepts. And if there are no x-intercepts, there are no solutions. We could go further into this thing and start talking about our imaginary solutions. We would have to get this thing now into the correct forms in order to either use the quadratic formula, or we would have to use any other method of solving that we've talked about to get those imaginary solutions. But this one has no solution. One thing I intended to touch on with this vertex form is the fact that why they call it the vertex form. Let's notice something about the vertex first of all. Let's identify our vertex again. Recall that it was at 1, 3. And see where these values make themselves known into our vertex form here. 1 and 3. So what you notice, hopefully, you've noticed, there's the 3 value, and there's the 1 value. The reason why this works this way, and that's why it's called the vertex form, is the vertex form is x minus the h value squared plus k. Now the h value is the x value of the vertex, and the k value is the y value of the vertex. We'll get further into these as we move further into our parabolas, but this is something that is helpful to touch on early on these things. Notice again that the h is the opposite of 1, but that's why it's called vertex form, is because you can immediately extract out the vertex. This last one we're going to look at has no particular form that I can recognize. It appears to be factored, but there's no necessarily factored form. This is just a random set of values. But one thing we want to highlight is that the y is set equal to the entire function. So if we have the y set equal to this function, what that means is we can just graph this thing. And I've already done that. I'm going to let you take a look. You can see I've typed the equation into my y equals right there. And then I got a bunch of ordered pairs coming out here. Let's take a look at those things that are most important to us. First of all, We have a 0 value here, and we have a 0 value there. Let's point out the coincidence of this thing. -6, not a shocker because with this is in factored form, that's our value, the same thing with 2. But we do have our x-intercepts. Our x-intercepts, let's go ahead and put these as ordered pairs. -6, 0, and again, make sure you recognize those are our solutions. That's what we're working on. We're just going to cover a few extra things. Now my y-intercept is where x is equal to 0. Well, that's right here. Try that again. Right there. So my y-intercept is at the point, and this is a location. The y-intercept is at 0, -4. I'm going to plot a few of these points while I'm at it. -7, 3. We've got a point at -6, 0. We've got a point at -4, -4. We have a point at -3, -5. We also have a point at -1, -5. So you see that value did not pair out. I'm going to learn what that number is in just a minute, but now we're going to start seeing that symmetry. 0, -4, which was our y-intercept. We had a point at 2, 0. And again, symmetry. So we're going to have a point at 3, 3. And then we have a point at 5, 11, which is off the graph. But 4, 20/3, that's going to be just under 7. So, I mean, we could sit here and try to plot that point, see what that looks like. But here's what we've created, our parabola. I'm going to hold off on the vertex for just a moment because I would like for it to be as accurate as I can. And this next point is at -2, -16/3. Now, I don't know what 16/3 is just off the top of my head, so we're going to go ahead and see how accurate we can get on this thing. So we have 15, and it's 5 1/3, and it's negative, of course. So we're going to go -5 1/3. That's at the value here. And I'm going to go ahead and name that plot while I'm at it. -5 1/3. So now we have all the important parts to this parabola. So let's go ahead and name them. First off, our axis of symmetry. Remember, the axis of symmetry is the x value of the vertex. So that would be x equal to -2. This one also has a minimum. Unfortunately, I picked all examples that had minimums, but if it would have opened downward, we would have had a maximum value. So our minimum value is going to be -5 1/3. Forgot my negative sign down there as well. Excuse me. We have our graph that's opening upward. So there's all of our parts to our equation there. Now I'm reminded, I'm going to go back and take a look at this. I'm not sure how this is going to go on the recording, but I meant to mention something on the vertex form. We'll take a look.